So, what we're going to talk about next is, this decay is, this decay is caused by having too many neutrons or an unstable amount of neutrons. And when these neutrons fall away, they disappear from the nucleus, right? Because in alpha particles, the neutrons, are physically ejected, and the beta particles, they are destroyed into their constituent parts. So what that means is that the nucleus now has less neutrons. Now, as we know, neutrons make up weight. So what that means is that the weight of the atom goes down. Let me say that again. Because in decay, we are getting rid of neutrons, and neutrons are what gives the atom weight, radioactive decay means that a material will physically decrease in weight. Let's have a look at this in a bit more detail. Right, so here we have a graph of strontium-90, okay? And this is what they call half-life, okay? So imagine we had 1 kilogram of strontium-90 in a cupboard, all right? After 30 years, there'll be half of it left. And this is what's considered to be called half-life, okay? And then after 60 years, there would be whatever, this point looks to be just before 60, is about, 0.25, and then just before 90, maybe 80 or whatever it is, half again, and then half again, and then half again, half again, half again. All right? And these halves are, kind of measured that way too. So sometimes they talk about number of half-lives. So 1 half-life is 0.5 or half of it, all right? That'd be 30 years. 2 half-lives is half of a half, which is a quarter, so that would be just before 60. 3 half-lives is half of a half, which is 1/8, so it would be, where it is, 1/8 down here. All right, and then 4 half-lives is a half of a half, and that's 1/16, which is somewhere down here. Does that make sense? So the number of half-lives is sometimes talked about that too. All right, so let's have a look at this question. 100 grams of strontium-90 is left in a cupboard for 75 years. Don't leave strontium-90 in your kitchen cupboard. It's a bad idea. For 75 years. So let's have a look. Let's see if we can have a look at this. So very roughly, 60. Let's imagine that's 75 there, because that would be 60, 70, 80. Let's imagine that's 75 there. We'll roll across. Okay, and let's imagine that's about 2. So we would say, after 75 years, your 100 grams of strontium-90 would turn into about 20 grams. Does that make sense? Good. Let's move on. Okay, what we're looking at here is a practical application of all this decay stuff. This is a smoke alarm at its most simple. Okay, what we have here is an alarm, okay, that's connected to a battery, and while the battery has a circuit, okay, the alarm stays silent. All right. The moment you disconnect the circuit, the alarm will go off. Okay. So while there is a circuit between all this, the alarm stays silent. But when the circuit is broken, all of a sudden, the alarm sounds. All right. So it's up to the Americanium 241 to do its funky business and make that work. So how does that work? So Americanium 241 undergoes alpha decay. So it emits alpha particles. These alpha particles, remember that they're 2 neutrons and 2 protons, so they have a positive charge. They knock electrons out of the air. All right, so you end up with positive parts and negative particles. So you end up with these positive particles, right? And the electrons come off here. All right? So what that means is the electrons end up attaching to the positive plate, and the positive particles attach to the negative plate. So what this does is this creates the circuit that the alarm needs, right? So it's come along here, the electrons created here, and the positive particles go there, and that creates the little charge that allows the circuit to be completed. All right? Perfectly fine. All right? And, you know, I think that's got a half-life of about 75 years, so we've got plenty of time to keep on using this smoke alarm. However, if there's a fire, if I'm cooking toast and, you know, I burn it, there's smoke appears, all right? And what the smoke does is it comes up and it covers these plates with smoke, okay, with smoke particles. And now these plates are covered with smoke particles. These electrons and positive particles are no longer attracted to them, to those plates, because they no longer have a charge. They're covered in smoke, right? And because they no longer have a charge, that means the circuit is now broken. And because the circuit is now broken, that means that the alarm goes off. Okay, pretty neat, yeah? All right, so this is one application of this alpha decay that's used in your house now. Yeah, so what I want you to do is go to chapter 6.2, look at the blue words, copy them to Quizlet, and I'll see you in class.